Are you tired of sending off a 3D print only to suffer random printing problems and frustrating filament failures? There's no question that 3D printing success can sometimes feel like rolling the dice. But what if I told you I have the solution for trouble-free 3D prints every single time? This is the ultimate 3D printing checklist, and in this video I'll walk you through every step you need to know for successful 3D prints. My name is Angus and this is Maker's Muse. Let's get started. This checklist is broken up into 3 separate sections, which I like to call pre-flight checks, slicer checks, and finally, printer checks. Work your way down the list, checking each one off as you go, and you'll be sweet. Starting with number 1, and the most important of all, is your 3D model ready to go? This only applies to models you've designed yourself, but it can be very easy to jump the gun and send prints that aren't quite ready to the 3D printer, which wastes time and material. I recommend double checking a few key dimensions and thinking about how it'll actually be printed. Maybe a certain orientation can remove the need for support material, or maybe certain areas are a bit too thin and need strengthening. This stuff gets easier with experience, so don't worry too much about it initially, but it's something to definitely keep in mind. However, this next one is something that still catches me out on the regular. Is the model you're 3D printing the correct one? It's all too easy to accidentally slice and print an outdated design, especially if you're rapidly iterating on something you're designing in-house. And once you import the mesh file into your slicer, it will cache it like in memory, so even if you save a new version over the old file with the same name, it won't actually update. So be sure to give your models a logical naming convention, letting you know which is the most recent version, and I recommend just deleting the model in the slicer and reloading if you're at all unsure. Happy? Good. Let's move on to the slicer, starting with your print profile. Have you set it to the correct 3D printer? If you slice for the wrong 3D printer, often the printer will still try to print, but things can go south very quickly indeed. So be sure to select the correct one from the drop-down menu. If you don't see your printer, you'll need to select it from the printer preset wizard, depending on the slicer you're using. I'm using Orca Slicer in this example, but the process is much the same in Prusa Slicer, Cura, and many others. Unless you have a very unusual 3D printer, or it's got proprietary hardware and slicers, you'll find it in these lists. So select the correct printer, and then now you'll need to decide what filament you're going to use. Every filament needs different printing parameters, which include temperatures, print speeds, and more. So be sure to check your roll to see what it says and select the correct filament profile from the drop-down menu. Like with the printer, you can find lots of filament presets in the wizard. For more standard filaments like PLA+, the default generic profile is usually just fine, but the wizard will have settings for a huge range of different filaments from different manufacturers. So it's worth checking to see if there's one that's been perfected for that exact filament for your exact 3D printer. However, for super experimental filaments like foaming TPU, your best bet is to visit the manufacturer's website directly and find a preset there. It is very possible to create a preset from scratch and fine-tune your own filament profile, but take it from me, it's a challenging and time-consuming process, and it's very easy to absolutely ruin your 3D printer if you get it wrong. Like temperatures, if you have a temperature too low and you print a high temperature filament, you'll jam up the hot end completely. So it's best left to something you do down the line when you gain a bit more experience. And one last thing on filament choice, different print surfaces need different temperature settings. So if your 3D printer can use a range of print beds, select the one you intend to use in your slicer. If the slicer throws an error at you, then that print bed probably isn't suitable for the filament you're intending to print. All right, so we've got the correct printer, we've got the correct filament, and then now you have a choice. Do you want your 3D print to be strong, look good, or print fast? This decision will determine the slicer preset you choose moving forwards. For regular prints that don't need a crazy amount of strength, stick to a layer height between 0.15 or 0.2 millimeters and a nice and light infill setting. This middle of the ground setting is usually the default. For example, with a U1 in Orca Slicer, the optimum print setting has a layer height of 0.16 and a cross hatch infill pattern at a 15% density, which is quite sparse. If you're new to 3D printing, please stick to the defaults. These settings are designed for print success in the majority of cases, and fiddling with these settings when you don't really know what they do can really mess up your print. If your print, however, needs to look pretty, then a finer layer height is what you're after, like this preset, which has a layer height of 0.12 millimeters. If your print needs to be nice and strong for functional use, then the print will need more perimeters and a denser infill. This setting bumps perimeters up to 6 and increases the infill density to 25%, which will use more material and take longer to print, but result in a stronger part. However, if you want your 3D print to complete super fast and don't care at all about strength or appearances, then a draft setting is what you're after. These presets will have a super coarse layer height of 0.24 millimeters or higher, and a very sparse infill setting, and they print really fast, but the parts are only really good for testing and iterating quickly, and not really suitable for end use. All right, so we've got the correct printer, we've got the correct filament, and the correct printing settings. Let's bring in that model. Is it oriented correctly, or does it look wrong? In the slicer preview, you can see how the part will be constructed layer by layer, and this is a great way of picking up on any problems. Your slicer might also throw up a warning if things aren't looking good, and it's important you pay close attention to them. In this case, the slicer is warning me that the print has a floating cantilever. That means that part of the model is unsupported, and with FDM/FFF 3D prints, they need to be supported during the printing process, or it'll just try printing in midair and fail in spectacular fashion. Unless the part needs a specific print orientation for some specific reason, I recommend using Auto Orient. This will position the part in the most optimum orientation, but some parts may still need support material, so take a look at the preview and any warnings, and then decide if the parts are still forming over thin air, then enable support material. If you're just getting started, then it's safe to just use the automatic normal supports, but do feel free to play with these different support settings till you get the result that you like. If you'd like to learn more about how to minimize support material or remove the need for it altogether, then you should definitely check out my ebook, The Ultimate Book of 3D Printing Tips and Tricks. In the ebook, I go into great detail on various tricks you can use to minimize or remove the need of support material altogether with modeling tricks and slicer tweaks, as well as many other ways you can supercharge your 3D printing experience. You can find the link in the video description below. And with that, there's one final slicer check. Are there any thin sections that might fail to adhere to the print bed? You want a nice solid first layer to stick your print down, and thin parts, like this example here, can really struggle with that and fail annoyingly halfway through the print. In that case, you want to enable a brim. A brim massively increases the surface area of your first layer, helping the part stay stuck down during the printing process, but once it's done, you can easily just peel it away. A brim is cheap insurance for your 3D print, so I usually just leave it on auto. If a slicer is suggesting you need one, then you probably do. If you're happy with your settings, then be sure to save the printing project for future reference. But wait, don't hit print yet, because it's time to set up the 3D printer. Get your material and make sure it's the same as you chose in your slicer, because mixing it up is way too easy to do. If it's PLA+, for example, then all you need to do is carefully load it into the printer and make sure it's not tangled. You can think of the spool like fishing line. You never want to let go of the end, because when it knots and tangles, it'll kill your print. Guaranteed. If you've got a tangle, then there's a few tricks you can use to remove it. I like to unwind the spool under tension until I find where the knot is, and then I pull it out and undo it that way. Or if the tangle's minor, you can actually loop the spool through the knot itself to undo it while it's still attached to the 3D printer. It's definitely quite the technique to learn how to untangle spools, so it's best avoided at all in the first place. However, some 3D printing filaments need to be dried before you can print with them. These are filaments like TPU, PETG, and nylon, and if you don't dry them, the print's going to look absolutely terrible. I try to plan ahead and dry these filaments the day before, but keeping these filaments in a dry box or in a sealed bag with desiccant between prints definitely helps. I use this filament dryer from Soval. It's not sponsored, there's many similar units out there, but it's very, very handy to keep around, and it works fairly well. Next, is there even enough filament left to complete your 3D print? This can be difficult to judge, and it's not the end of the world if the filament runs out because most modern 3D printers actually detect it and will pause and wait for you to come and load more, but it's certainly annoying and best avoided. If you're only printing small things, then I would just send it, quite honestly, because if it runs out, no big deal. But if you're 3D printing something really large and you need it to succeed, then I'd recommend actually weighing the spool first and then minusing the weight of the spool from the result to figure out how much filament is actually left and comparing it with your print's preview material estimate. I personally like to double the estimate for safety margin, but honestly, if you're in doubt, smack on a new roll, especially for those important prints. Filament is cheap, but failed prints waste time, and time is money. And also, if you're changing filaments, and especially changing colors, make sure you purge the previous material completely, because when you go from a dark filament to a lighter filament, it can take quite a while for that color to change, and you don't want the first layer of your print to be all gross colored as it's finally catching up to the color you've actually loaded. Is your print bed clean? Even the best printing services will fail to stick your prints down if they're dirty or covered in greasy fingerprints. And I would say these days, this is probably the #1 reason people have their prints fail and they're so confused as to why. The print bed needs cleaning. The safest way to clean PEI print beds is to use hot water and dish soap, letting the plate fully dry before use. But a quick wipe of the bed with isopropyl alcohol on a paper towel while it's still cool is a convenient way of keeping the print bed functional between prints without having to do a big process to clean it. And if you're using any adhesion helpers like glue stick or sprays, this process will keep the adhesion helper lasting longer rather than stripping it completely between every print. And just on that note, if you are printing a particularly challenging material, adhesion helpers add that little extra bit of stick to the print bed. You can use cheap glue stick for many prints, or you can buy purpose-made adhesion helper sprays. But keep in mind, the aim here is less is more. You don't want a thick, gross coating to ruin that first layer of your print. Ideally, you want it to barely see the coating on a perfectly clean print bed, because a thin coating of adhesive helper on a perfectly clean print bed will stick incredibly well. The only exception here is to be aware of when printing with filaments like TPU or PETG, these materials can actually stick too well to print beds and fuse to them semi-permanently. In this case, I actually use glue stick as a kind of release agent between the print and the bed, which helps keep it from being stuck down too much. It will still print fine when hot, but it lets it release when cold. And it's really important to remember, because you don't want to ruin your brand new printer by printing the wrong material straight onto that print bed. Now, take a moment to look around your 3D printer. Is there any debris, tools, or failed prints floating around inside that might cause a jam and failure as the printer moves around? Now, this might sound silly, but I knew someone many years ago who kept their hot air gun at the bottom of their 3D printer. It was a MakerBot replicator, the old wooden one, and they were really confused why the print was failing after a period of time. Well, what was happening is the print bed was lowering down, and for large prints, it was catching on the edge of that hot air gun and then jamming and then failing, and the print would just be completely destroyed. So don't keep any tools in the printing chamber itself, and just take a look around, because sometimes it's just a small amount of a failed print that can get stuck between maybe the lead screw and the homing point, and that can be enough to stop the printer from homing and completely fail the 3D print. You don't want any of that, so make sure it's nice and clean. And now it's the moment you've all been waiting for. It's time to hit print and let your 3D printer do what it does best. I highly recommend watching those first few layers go down to ensure that nothing has gone wrong, because if these look good, it's highly likely that the print itself will be a success. But a bad first layer will almost always ruin a 3D print. So if it doesn't look quite right, it's a good idea to stop it, reset, and figure out what's going wrong. Maybe your filament settings weren't quite right, or maybe the print bed isn't as clean as you thought it was. By going through this checklist, you massively increase your chance of 3D printing success, and you can download a printable copy of this checklist in the description below. Print it out on something nice and big, A3 or ideally A2, and put it up next to your 3D printer for the benefit of yourself and especially others if you're using 3D printers in a makerspace or educational environment. Maker's Muse is kept independent thanks to your support. If you have any tips, tricks, or checklists that you run through before starting your prints, I'd love to hear about them in the comments below. Thanks for watching, guys. Bye.